Baiklah, kita nak lihat kepada subtopik diffraction by a single slit. Okay, so kita lihat kepada subtopik yang pertama, apa yang dimaksudkan dengan diffraction. Alright, so diffraction is defined as the bending of wave around the corners of an obstacle or aperture that is physically the approximate size of or even smaller than the light's wavelength. Okay, so kalau kita ada opening which is much larger than the light wavelength, the bending will be almost unnoticeable. Okay, so kalau kita lihat kat sini, alright, which is opening kat sini, the opening of the slit obstacle kita, okay, which is lebih besar daripada lambda. Okay, so the bending will be almost unnoticeable. Alright, tapi kalau A kita, okay, kita punya single slit, alright, distance of a single slit, okay, lebih kurang sama dengan lambda ataupun less than the value of wavelength. Alright, so kita akan lihat berlakunya diffraction pattern dekat sini. Okay, which is diffraction adalah bending of wave. Okay, which is light travel. Okay, so lambda travel melalui kita punya slit. Alright, so berlakunya diffraction pattern. Okay, yang ni kalau A kita more than lambda. Alright, yang ni A less than lambda. Okay, so kita lihat kepada criteria of diffraction. Okay, so when diffraction occurs, wave direction changes, the wave velocity V changes, alright, the wavelength lambda is unchanged, and frequency of F, okay, frequency ataupun simbol F is unchanged. Alright, tapi the amplitude A of the diffracted wave is smaller compared to the incident wave as the energy is spread out over a large surface. So kat sini kita kata energy akan spread out. Alright, so means that the amplitude dia akan menjadi smaller. Okay, none of the properties of wave are changed by diffraction. Okay, the wavelength, okay, kita ulang balik yang tadi, lambda, frequency, period, speed are same before and after diffraction. Again, the only change is the direction in which the wave is travelling. Alright, the amount of diffraction akan depends kepada wavelength of the light wave, okay, ataupun kita punya source, and the size of the gap, okay, which is A tadi. Okay, the size of gap slit where the wave is travelling through. Okay, so kalau lambda increase dan A kita constant, diffraction is more. Kalau A kita berkurang, okay, the size of the gap ataupun slit berkurang, and lambda constant, so diffraction is more. Tolong betulkan dekat buku awak ya. Alright, seterusnya. Okay, seterusnya, subtopik seterusnya, kita nak explain with the aid of a diagram the diffraction of a single slit. Alright, so kalau kita lihat dekat sini, kita ada central maximum, center bright ataupun zero order maximum, and then kita ada first order minimum ataupun first dark, and so on lah. Okay, so kalau kita lihat kepada figure A, okay, figure A shows a wave front passing through a narrow slit of slit width A lah. Okay, according to hygiene principle, each point on the wave front is a source of spherical wavelet. Okay, so the superposition of this wavelet akan produce the diffraction pattern on the screen. Okay, so figure B pula nak show tentang apa? Okay, figure B show the wavelet going straight forward. Alright, all travel in the same distance to the screen. Okay, thus they arrive in phase and interfere constructively to produce the central maximum of diffraction at theta sama dengan 0 darjah. Okay, that's why kalau kita lihat dekat sini, kita ada central bright. Okay, which is the central bright. Okay, the amplitude lebih besar. Okay, the situation is different at points away from the center. Okay, that one is at the center lah. Okay, so situation is different at point away from the center. Okay, which is kita akan lihat pada figure C. Alright, so untuk figure C ni saya akan explain based on this part. Okay, for example, alright, if the first minimum ataupun first order minimum is produced at point P, alright, so apa yang akan berlaku, kita akan lihat kepada pulse different. Alright, so kita lihat dari segi size triangle di sini. Okay, which is dekat sini kita ada distance which is A per 2. Kita ambil the smallest one. Okay, this one is theta, and then this one is a path difference. Okay, so path difference akan menjadi sama dengan apa? Path difference ni adalah sama dengan lambda per 2. Based on kepada kita punya teorem Pythagoras, sin theta adalah sama dengan delta L divided by A per 2. So, kita rearrange equation, kita akan dapat A sin theta sama dengan lambda. Alright. So, okay, if the path difference between ray A1 and ray 2 adalah lambda per 2, alright, the path difference for ray 3 and ray 4 and path difference between ray 5 and 6 also just the same. Okay, so maksudnya those pair of wavelet akan interfere destructively. The superposition of all wavelet akan produce perfect destructive interference. Alright, so the key idea that every point on the wavefront can be paired with another point that is A per 2 away. Okay, so kalau kita lihat tadi kan ray 1 dengan ray 2, dia punya distance adalah A per 2. Okay, if the path difference is lambda per 2, the wavelet will arrive at the screen antiphase and interfere destructively. Alright, so that's why lah kita akan dapat equation for complete destructive interference adalah A sin theta sama dengan n lambda. N is a number of order. Alright, so kita ada dua equation untuk distance between n order minimum dark fringe dengan center bright, and order maximum bright fringe dengan central bright. Alright, so ini adalah equation untuk central bright dengan dark fringe. Alright, ini adalah equation untuk jarak antara central bright dengan bright fringe. Alright, so kita just gantikan saja menggunakan equation ini. Alright, so kita proceed kepada the last subtopic. Okay, kita nak lihat kepada 8.6 diffraction grating. Okay, apa yang dimaksudkan dengan diffraction grating? Diffraction grating is a glass slide with large number of equally spaced parallel. Okay, so kita ada inilah kita kata large number of equally spaced parallel slit. Okay, so this one is slit. Alright, D adalah slit separation, and then this one is line. Okay, light is reflected by the narrow slits, and the light that emerge from the slit produce interference. Okay, so kita dah buat eksperimen kelima. Okay, if n is lines per unit length, then the slit separation is given by D sama dengan 1 over n. So kita use equation untuk cari slit separation. Okay, n adalah number of slit per unit length. Okay, seterusnya macam mana formation of diffraction terbentuk? Alright. So, untuk diffraction grating, according to Huygens principle, each point on a wavefront acts as a secondary source to produce wavelet. Okay, when the wavefront arrive at the slits of the diffraction grating, the wave are in phase. Okay, as it pass through the slit where it becomes secondary point source, P, Q dengan R tadi, it produce wavelet. Okay, the tangent of the wavelet akan form new wavefront which then interfere each other. Alright, so the interference pattern consists of series of sharp and widely spaced bright fringe due to constructive interference. Alright, so ini adalah condition for bright fringe in the pattern at angle theta, which is given by D sin theta sama dengan n lambda. Okay, so untuk center bright, the M is equal to 0. Alright, next kita akan lihat the last equation. Kalau soalan suruh kita calculate the maximum number of bright fringe yang terbentuk pada diffraction grating, kita boleh observe, okay, based on this equation, theta akan menjadi maximum sama dengan 90 darjah. So based on this equation, kita akan dapat n maximum adalah sama dengan D divided by lambda. Alright, so untuk mencari maximum number of order maximum, kita akan menggunakan equation ini. Alright, so kita dah habis chapter 8. Kita akan continue dengan chapter 9. Thank you.